minutes. Hello, math humans. We're going to do 4.1 today. We're going to be starting our Trig unit. Actually, we have 3 chapters of Trig. Our objectives are that we're going to do lots of review vocabulary. We're going to talk about radians, positive and negative angles, coterminal angles, arc length, and then the area of a sector. So trigonometry, cool name, is the study of sides and angles of triangles. So that's kind of cool to know what it actually means. So it's going to be the study of sides and angles of triangles. If we talk about an angle is composed of 2 rays, okay? Both of them have a vertex when you put them together. This would be the initial side of the angle, and this is going to be what's called the terminal side of the angle, okay? If we put that angle on a coordinate system, which is where we often do math, the positive rotation is going to be in the counterclockwise direction, which means that the negative rotation is going to be in the clockwise rotation. Another way to think about it is that the positive rotation is across the top and the negative rotation is across the bottom. If I put one of my angles on my coordinate system, and so let's say here's my angle, this is the initial side, and then this is my terminal side. The initial side is almost always on the x-axis, okay? All right, and I'm just going to write that this is counterclockwise. And when I'm thinking of these, I typically think across the top and across the bottom, and this is clockwise. Okay? The next vocabulary word that we want to think about are coterminal angles, and these are all words that you have heard in your previous math life, but we want to go back and re-chat about them. So coterminal angles are 2 angles that end in the same terminal position. And hopefully you can read my cursive. I tend to write cursive when I'm trying to write faster. All right? So here's what it might look like. So let's say here's my coordinate system, and I have this angle. Well, this is one rotation. Coterminal would be the opposite rotation, and they would both end in the same place. So let's just start with our first example. So example number 1 says to sketch, hang on just a sec, there we go, sketch the angle and find a positive and negative coterminal angle. Like with many things that we do, when we report, we want to make sure that we label well. So the first part for A, we're going to be given 30 degrees. So the first thing that I would do is draw that angle in standard position. So 30 degrees would be right here. So my original angle is 30. To get a positive in the positive rotation, I'm actually going to take a lap in the positive direction. So my positive coterminal would be 360 degrees, which is a lap, plus the original 30 degrees, so that would be 390 degrees, okay? And then my negative coterminal, do it in a different color, means that I'm going to start here, and I'm going to go negative. So my negative coterminal is going to be, I'm going to go a negative 360 degrees. So technically I'm going to go all the way to the axis, and then I'm going to back up 30. So then plus that 30 degrees, and I'm going to get a negative 330 degrees. So when I report, I would write that my positive coterminal is going to be 390, and my negative, I'll write the word negative, coterminal is going to be a negative 330 degrees. Now notice that I'm putting my units. The default is degrees. In Big Kid Math, we often do radians. Radians does not show usually as a unit of measure. It would be naked and have no units. All right, the next example, same thing, would be find the positive and the negative coterminal for 120 degrees. So I'm going to sketch my angle. 120 is here. This angle is 60 degrees. So if I went all the way to the x-axis, this would be 180 minus 60. This is 120 degrees. Okay? This little angle right here is called the coterminal, is called the reference angle, and you will always be expected to label that reference angle, okay? Sorry, brain and mouth and hand aren't all working at the same speed. So if I want to do my positive coterminal, because I have this angle, I'm going to have to take a lap. So my positive coterminal would be 360 plus the original 120, so that's going to be 480 degrees. My negative coterminal, I'm going to go all the way to here, which is a negative 180, and then I'm going to go 60 more degrees in the negative direction, and that's going to be a negative 240 degrees. So when I report, I would report that the positive coterminal is 480 and the negative coterminal is a negative 240. There's no reason to take more laps than you need to, so just the first is sufficient. All right, so now we're going to talk about measuring angles. So just a little bit of review from geometry. There are 360 degrees in a circle. There are 180 degrees in a straight line, okay, which is convenient because when we start talking about our coordinate system, 180 degrees is in my straight line. Radians is the expectation for Big Kid Math. There are 2 pi radians in a circle. Okay, there are pi radians in 180 degrees. So those become your conversion factors. Gradients are another type of unit, and we're not going to discuss this. This was designed in the 1700s, and it was used for the metric system, which is actually kind of interesting to know where the angles come from. There's another type of units that our book would cover. It's called degrees, and then minutes and seconds, where you're breaking an angle down into degrees, minutes, and seconds. We are not going to cover that in this course. Alrighty, so now let's do a unit conversion. Different people teach it different ways. I teach it like dimensional analysis because dimensional analysis is really easy, because all I have to worry about is making sure that my relevant units cancel. So let's do a couple of examples. So let's say I want to just take 1 radian, just so we understand what the size of a radian is. And I want to convert that to degrees. Then I'm going to set up my problem. I have 1 radian. I set up my little dimensional analysis. There are pi radians in 180 degrees. The radians cancel, and I get 180 divided by pi, and when you do that math, you get 57.296 degrees. So 1 radian is equal to 57.296 degrees. Alrighty? The default for higher level math is radians. When you get to calculus, 99% of the problems are going to be done in radians. So that is why we spend so much time in PreCalc going back in remembering how to do that math. So for example number 2, we're going to do some conversions. Do conversions. Okay, so I don't memorize placement, I just do dimensional analysis. So for A, we're going to have 135 degrees, alrighty? If I convert that, my unit is degrees. There are 180 degrees in pi radians. So if you'll notice how I set it up, I don't have this ratio, well, I do have the ratio memorized, but I know that I have degrees in the numerator, which means I have to have degrees in the denominator so that my appropriate units cancel, leaving the unit that I want on the top, which is why we do dimensional analysis. When I'm converting to radians, it is important that you leave your angle with pi in it because that is the expectation. So when I do this math, I do 135 divided by 180, I get 3 pi over 4 and then radians. You don't have to write the word radians because if your angle has no units or if it has a pi in it, it is assumed that it's in radians. So then I'm going to go the other way for part B. I'm going to give you 9 pi over 5 radians, and I want to convert to degrees. So I'm going to draw my dimensional analysis. I have pi radians in 180 degrees. Radians cancels, pi's cancel. So this is 9 times 180 divided by 5, which is 324 degrees. So 9 pi over 5 is equal to 324 degrees. One of the biggest tasks that you have for pre-calculus is learning to think in radians. So sometimes we kind of will mix our degrees and our radians, but we need to learn to think about a circle in radians. There are only a couple of things that I'm going to ask you to memorize, and we're going to talk about it from our coordinate system. I will not ask you to memorize the unit circle. I think it's a waste of time, but I am going to teach you all of the individual components. So this is 0 or 360 degrees. It is also 0 or 2 pi radians, okay? This is 90 degrees or pi over 2. This is 180 degrees or pi. This is 270 degrees. This is 3 pi over 2. And then all the way around the circle is 2 pi. So I will expect you to have those memorized as far as radians. And then I only have 3 more. If I have 30 degrees, this is going to be pi over 6. 45 degrees splits the first quadrant. It is pi over 4. And then the last one that you need to know is 60 degrees, and that is pi over 3. I expect you to memorize those today, because from now on, I will be talking about my angles in terms of radians, and you need to memorize just what I've written here, and that's it. So now what we're going to do is we're going to do some coterminal angles using radians instead of degrees, okay? I still sometimes convert my angles to degrees if I'm unsure of where that angle might be, but I'm going to teach you how to do the math in radians. So we're going to start with a nice polite one. I want to find positive and negative coterminal angles. The other thing that you're going to hear me say a lot in this chapter is when in Rome. So there's a saying that says, when in Rome, do as the Romans do. In case you've never heard that before, do as the Romans do. For calculus or for pre-calc, what that means is if a problem starts in radians, you finish in radians, when in Rome. If the problem starts in degrees, you finish in degrees. So you follow the way the problem starts. Unless, of course, you're doing unit conversions, and then we're trying to balance back and forth between the two different types of angles. but for the majority of the time, you're going to follow the lead of the problem. So in this one, I'm going to be given 3 pi over 4, and I want to put it in to positive and negative coterminal angles. The first thing that you should do is draw your angle. So remember we said pi over 4 is 45, so that means there are 3 45s. So here's 1, 2, 3. Boy, that's a nice straight line. This is 3 pi over 4. So with radians, I'm going to teach you how to do positive and negative coterminal angles, and basically we're going to be adding and subtracting from the horizontal. Okay? So the first one I want to do is my positive coterminal. So for the positive coterminal, I'm going to take a lap. Remember that a lap is all the way around the circle. All the way around the circle in radians is 2 pi. So I'm going to go all the way around and then get back to my 3 pi over 4. I can't put these two numbers together unless I multiply this number by 4 over 4. So now the fractions can play together. 8 plus 3 is 11. This is 11 pi over 4. Okay? And I'm going to do my negative coterminal right here as well. So for my negative coterminal, I'm going to go a negative pi. So a negative pi. And then I'm going to go 3 pi over 4 plus 1 pi over 4 is going to get me to this location, right? Because 3 pi over 4 is 45. So I'm going to go one more 45. Notice that they're both negative. I'm going to multiply this fraction by 4 over 4 so that I can add the two fractions together. And this is going to be a negative 5 pi over 4. So what we need to learn to think about when we're doing our angles in radians is adding and subtracting from the horizontal axis. Okay? So I'm going to do another example. This is going to be example B, and I'm going to give you a unique angle. So 5 pi over 12. 5 pi over 12 is considered not a special. And by that, I mean it is not either a 30, 60, 90, or a 45, 45, 90, which means that it's not a pi over 6, a pi over 3, a pi over 4, or one of the quadrantal angles, the angles on the axes. So because it's not a special, I'm going to actually convert it so I know where it lives. So I have 5 pi over 12. I'm going to convert that to degrees. There are pi radians in 180 degrees, and this gives me 75 degrees. I'm going to do my math in radians, but I really needed to know where that angle was. So I'm going to draw my angle, and this is 5 pi over 12. And I'm going to do the exact same process that I did on the last one. If I want to do my positive coterminal, I am going to take a lap and go to that angle. Well, the lap is 2 pi, and then I'm going to continue 5 pi over 12. I need to multiply this fraction by 12 over 12 so that I can put the two fractions together. 12 times 2 is 24 plus 5. This is 29 pi over 12. Now for the negative coterminal, again, I'm adding and subtracting from my horizontal axis because it makes my life easier. So for the negative coterminal, I'm going to go all the way to a negative 2 pi, and I'm going to back up, go the opposite direction. So I'm going to go all the way to here, and then I'm going to back up to here. Notice I went the negative rotation, and then I went the positive rotation. And again, I multiplied by 12 over 12. 24 minus 5 is going to be, come on, brain, you can do it, a negative 19 pi over 12. So it's easiest when you're doing your angles if you are adding and subtracting from your horizontal axis. And then, of course, I would report politely, my positive coterminal is going to be 29 pi over 12. My negative coterminal is going to be a negative 19 pi over 12. Okay? All right. So the next couple of things that we're going to talk about, and we're going to be doing lots of things with radians over the course of the next 3 chapters. But the next thing that I want to talk about is arc length and the area of a sector. And I need to log back into my computer. When it goes long, it gets cranky. All right, so the next thing that I want to talk about is arc length. Section 1 is just kind of a conglomeration of many different things that are related to trig, kind of as our introduction. So if I take a circle, the circumference of the circle is going to be 2 pi r, and that's a formula that you've learned in previous math lives. If I want to break that circle down into pieces, and I want to consider just a portion of the circumference, that is called an arc. And the measure of the arc is equal to the measure of the central angle. So you learned this in geometry. Okay, and my black pen is about to die. So the central angle is this one. So let's say this is a 30-degree angle, then that means that the length or the measure of that arc is also 30 degrees. But sometimes we want to talk about the length of an arc. So it's like we took that arc and straightened it out and measured it in a straight line. So we have a handy-dandy formula that says S, which is arc length, so that would be as if I straightened out my arc, is equal to r, which is the radius of the circle, times theta. And theta is a variable that we use to represent angles. The caveat for this is it must be in radians. Okay? And if you get that portion wrong, you'll get this type of problem wrong. So it's a very simple formula. The length of the arc, not the measure of the arc, the two things are different. The length of the arc is equal to r, the radius of the circle, times theta. And theta has to be in radians. Along those same measures, let's say if I have a whole circle, I can find the area of a circle is pi r squared. But what if I want to calculate the area of a slice of the circle? Okay, so then that is called a sector, and the area of a sector is going to equal 1/2 r squared theta, and again, theta has to be in radians. Okay, so if it's not in radians when the problem starts, then you have to do your unit conversions. All right, I have 2 more examples and then we are done. So for example number 4, and lucky dogs, because the last time I made this video it was 50 minutes long. A circle has a radius of 4 inches. Find the length of the intercepted arc and it has a central angle of 240 degrees. All right, so there's our problem. And so what we're going to do is just kind of draw a picture to illustrate what's going on. 240 degrees is 180 plus 60. Okay, so if we had a whole circle, this would be the angle, 240 degrees, and I would be looking for the length of that whole arc. So my formula is that the S is equal to r times theta. But remember we talked about theta has to be in radians, so I need to do a conversion. I have 240 degrees. There are 180 degrees in pi radians, and so this turns out to be 240 divided by 18. The zeros cancel. 6 goes into both of those. This is 4 pi over 3 radians. Now, sometimes I do my unit conversions right in the problem, and I don't take the time to do this. So if I had set that up, I would have done S is equal to, my radius is 4, and then if I just did it all in one fell swoop, so I'm going to multiply by, I have 240 degrees, and then I would do my 180 degrees by pi radians. Then I can do the whole problem in one fell swoop, and when you do, you get that the length of the arc is 16.755 inches, and so then I report S is 16.755 inches. So typically when I do these, I just do the angle conversion right in the body of the problem. All right, one more example, and then we are done for today. Woohoo! So I have a sprinkler on a golf course, and it's going to spread water, because that's what sprinklers do, over a distance of 70 feet. That's an energetic sprinkler, and it rotates through an angle of 120 degrees. Find the area watered by the sprinkler. Alrighty, so again, I'm going to draw a picture just to illustrate what we have. So here's my coordinate system, and I have 120 degrees, which is right here. It's 60 degrees shy of 180, and then my sprinkler is going to make a pattern, and I want to know what is the area that it covers. So it says that the sprinkler covers a distance of 70 feet, so that means that the radius of the circle is 70. So I'm going to use my sector formula, which is 1/2 r squared theta. Remember that theta has to be in radians, and again, I'm just going to do my conversion all at the same time. So here's the half, and then I have times 70 squared, and then I have 120 degrees, and there are 180 degrees in pi radians. My degrees cancel, and so when I do this math, it's going to be 7 squared is 4900 times 120 pi divided by 2 times 180. And when you do that math, you're going to get 5131.268 square feet, and then I report my area. Alrighty. There are a couple of other formulas that the book likes to throw in, and I'll just include those at the end. So linear speed is going to equal arc length divided by time, and that's going to be S divided by T. And then if I want to talk about an angular speed, then that is going to equal the central angle divided by time. And because we're doing everything in radians, this would be theta divided by time. And in theory, we'd like to convert our theta to radians. Alrighty, that's it for today. Nice start to Chapter 4. See you soon.